Okay, so we'll keep working with trig functions today and right triangles. Um, we're going to find angles today, and we're also going to use special triangles. If you have a special triangle, then you don't need a calculator. So we'll do it with a calculator and without a calculator. So we have to use a similar strategy that we used in the previous lesson, and that is to label the sides. So if that's theta, then this is the opposite. And this must be the adjacent. And then this is the hypotenuse. We need to choose the sides that we know. We don't want, because here's a variable, an unknown, and here's another unknown. We don't want to have an equation with two unknowns. So we want to make an equation using the adjacent and the hypotenuse. And adjacent over hypotenuse is cosine. So we know that cosine of theta is adjacent over hypotenuse. And we're going to do inverse cosine of both sides just like you would divide to solve a multiplication equation. Here we're going to do, well, division is the inverse of multiplication. Here we're going to do the inverse of cosine. And then we have to do that on the calculator. And that looks like this. We need to be in, here we'll be in degree mode. So we go to mode, degree, enter. And then we use this button, cosine, but it's cosine to the -1, inverse cosine. So we go second cosine, 36 over 54, 48.19. Remember also that this -1 does not mean the reciprocal of cosine. It doesn't mean secant, so this means inverse cosine. Alright, pause the video and try that one. Theta, opposite. Adjacent, hypotenuse. And we know the adjacent and the opposite. We need a trig function that has opposite and adjacent, so that's tangent. Tangent theta is 19 over 3. Inverse tangent of 19 over 3. And on the calculator we get about 81.027 degrees. All right, pause and try that one. And opposite is over here, hypotenuse and adjacent. We know the adjacent and the hypotenuse. We need a trig function that has adjacent and hypotenuse, and so that's going to be cosine. Cosine of theta is 21 over 30. We do that on the calculator and we get about 45. All right. Now that we can solve for sides and angles, well, then they're going to ask a question to find all sides and angles. And we'll use capital letters for angles, and then their opposite side is a lowercase letter. All right, so we can start by finding the missing side. If we know two sides, we can do the Pythagorean theorem. A squared plus 14 squared equals 16 squared. And that can reduce to 4 times 15, or 2 radical 15. Okay. And let's choose an angle to find. How about we find angle A? So if we're going to find A, then this is the opposite, and there's the hypotenuse. That means to find A, we can do sine. Sine of A is opposite over hypotenuse. So A is inverse sine. We do that on the calculator, we get 28.96. And we know that we don't have to do trig again because we can just find B by doing either 180 minus 90 minus 28.96, or we could just do 90 minus 28.96. $61.04. Okay, try this one on your own. We're missing two sides, so we can't start with the Pythagorean theorem. We'll have to start by finding a missing side using trigonometry. So you can choose, you can solve for G first or E first. Pause and try that. All right, this is the right angle, so there's the hypotenuse, adjacent, and opposite. Let's go ahead and find G, so we're dealing with opposite and adjacent, so that means tangent. Tangent of 21 is going to be 9 over G. So G is 9 over tangent 21. On the calculator, we get 23.45. We could use the Pythagorean theorem. Maybe it's just quicker to do trigonometry. So we found G, we need to find E. And why don't we use the opposite and hypotenuse, so that'll be sine. Sine of 21 is opposite over hypotenuse. And on the calculator, we get 25.11. So now we know that's a side. That's not a degree. These are side lengths, not angles. And we just have to find the missing angle. So we can just do 90 minus 21. So we found side E, side G, and then we have to find angle G is 90 minus 21, and we get 69 degrees. And before we go on, let's review the special triangles. All right. A special triangle, one of the special triangles is a 30, 60, 90. And here we have an equilateral triangle. So pause the video and see if you can do something to this triangle to create a 30, 60, 90 triangle. We know that all the angles are 60 because all the sides are equal length. So that means if we divide it down the middle, we'll get a right angle. This will be split into a 30 and a 30. And now we have a 30, 60, 90. That's a 2. This got bisected, so there's a 1 there. And then we can find the missing side using the Pythagorean theorem. So it's going to be 1 squared plus a squared equals 2 squared. So we can see that That missing leg is radical 3. We want to memorize these sides. And the 45, 45, 90, if we did have a 45, 45, 45, 90, we just have to know the sides. What are the ratios of the sides? So if that's a 45, then 90 minus 45 is this one, because we go 45 plus 45 plus 90, they all have to add up to 180, so we know it's a 45, 45. It's an isosceles triangle, so we might just, well, here it told us that it was 1, so that means because it's isosceles, that's a 1. Then with the Pythagorean theorem, we know that's a radical 2. So we want to memorize these side lengths. All right, cotangent of 30. So that'll be the 30, and that's all we know, but we know that from what we just did with the special triangles, we have those memorized, and we know that that's a 1, 2, radical 3. Then we just do cotangent of 30 is the adjacent over opposite. The adjacent is radical 3 and the opposite is 1. We were able to evaluate it without a calculator. All right, draw a 45, 45, 90 triangle and then find cosine. Pause. Cosine is adjacent over hypotenuse. So the adjacent is 1, the hypotenuse is radical 2. And we could get radical 2 over 2 if we rationalize the denominator. Sine of 60 degrees we don't have to make that the 60-degree angle. We could have made it down here, but I just drew this triangle the same orientation as this one. And we're going to do sine of 60, so we want the opposite over hypotenuse. So that was evaluating trig functions without a calculator. Now we can find angles without a calculator. And we're going to have cosine is going to be adjacent over hypotenuse. So now we draw a triangle with theta, and the adjacent is radical 3. The hypotenuse is 2. If we do the Pythagorean theorem, we'll get a 1, or just label that from memory. It's a 1, 2, radical 3. And if we have those sides memorized, then we know that this is the smallest angle because it's opposite of the smallest side. Radical 3 is bigger than 1, so there's a long leg, short leg, hypotenuse, and this must be, if our choice is 30 or 60, then this must be a 30. Okay, and pause, try this one. The opposite and the hypotenuse. Now this looks different from what we saw, which was a 1, 1 and a radical 2, but that radical 2 is around there. If this is confusing, then you could always just change that to a 1 over radical 2, or you could do the Pythagorean theorem, and we would get another radical 2 over here. And now we see that it's isosceles. An isosceles right triangle must be a 45, 45, 90. Secant theta equals 2. Pause and try that one. So we know the hypotenuse is 2, the adjacent is 1, and if we did the Pythagorean theorem, we'd see that that's a radical 3, or we could just do it from memory, 1, 2, radical 3. And that's the longer leg, so that should be the bigger angle. The larger of 30 and 60, so that must be a 60 because that's the long side, long leg. So then we get 60. All right, we'll stop there.